So we have two concentric circles, and the center of both of these circles is the center of mass. Then we have one mass m on this side and a bigger mass m on this side. And then say call this distance r1 and this distance r2. So first we'll start by finding these distances r1 and r2 respectively. And before we do that, we'll assume this whole length will be d. So if we take this point to be our origin, we can set up the center of mass equation as m, since this mass m is a distance d away from the origin, md plus the small mass is at position 0, so that won't have any effect. And that would be divided by the sum of these two masses, so m plus m. If we put all of this together, we get capital M divided by capital M plus small m times d. Now we'll set up the expression for the centripetal force acting on this big block m. So m v squared over r is equal to the gravitational force that's acting between them, which is g small m capital M divided by the distance between them squared, so d squared. The two big m's cancel, and over here instead of v, I'll replace this with their angular velocity, which is omega r, and since there was a v squared up there, this whole expression would be squared too. So we get omega squared r is equal to gm divided by d squared. Now this r for m, since, oh wait, I made a mistake in the diagram here. So this smaller mass is rotating in between. So this distance r2, that's basically this part. And to find that, we can simply take the total distance d and subtract from that this distance that we initially calculated, which was the distance that the center of mass was away from point m, small m. So for big M, the distance would be, we'll call that r2, and that's d minus this expression over here, m over and if we simplify this fraction, we get small m divided by big M plus small m. Now we'll substitute this expression that we got for r in our expression involving our omega. So omega squared, instead of r, we're putting m over m plus m is equal to gm divided by d squared. We can simplify this a bit by taking small m divided by big M plus small m to the other side, and after some simplification we find that this evaluates to g multiplied by big M plus small m divided by d squared. Sorry, there's another d here. So this would eventually become d cubed over here. Now we can set up our relationship between the time period and omega. So t equals 2 pi over omega. So we can square both sides. We get t squared equals 4 pi squared over omega squared. And then for this omega squared, we'll put in this expression that we solved for right here. Once we do that, we get 4 pi squared over g capital M plus small m. This denominator would go in the numerator. So d squared times d, that's just d cubed. And this is our final expression. 4 pi squared d cubed times g m plus n.